Hello, welcome to the first video of Volumetry AP Biology. So today we are going to be going over the AP Biology background review. AP Biology. Throughout this course, you'll study the scientific principles, theories, and processes that govern living organisms and biological systems. It's going to be broken down to skill sets and practices. The practices that you'll be able to expect it to discover and apply will be concept explanation, analyze visual representations like graphs, determine scientific questions and methods, represent and describe data, perform statistical tests and data analysis, develop and justify scientific arguments for using evidence. The big ideas. The big idea one. Evolution. The process of evolution drives the diversity and unity of life. Big idea two, energetics. Biological systems use energy and molecular building blocks to grow, reproduce, and maintain dynamic homeostasis. Big idea three, information storage and transmission. Living systems store, retrieve, transmit, and respond to information essential to life processes. Big idea four, system interactions. Biological systems interact, and these systems and their interactions exhibit complex properties. The content of AP Biology will be broken down into these four big ideas. You're going to want to know these four big ideas as they are broken down into enduring understanding, the long-term takeaways, learning objectives, essential knowledge, and these big ideas show up all over AP Biology. You're going to be seeing these big ideas in every single unit and they may even overlap. So, what you learn in each unit cannot be forgotten because it is important for other units as well. So, for the review of biology, the scientific method everyone knows it's a step-by-step process used by scientists to investigate questions, gather evidence, and draw conclusions based on experiments and observations. Right here's the scientific method. Make an observation, ask a question, propose a hypothesis, design an experiment, collect data, and draw a conclusion. To form a hypothesis. Hypothesis, what is it? A hypothesis is a prediction that can be tested by recording more observations or experiments, often heard as if, then, because, but does not need to be in that format. The if is usually the manipulated variable, the then is the responding variable, and because is an optional explanation. The results from a hypothesis can either support or refute the hypothesis, but you would never want to say that a hypothesis is correct or the hypothesis is incorrect. Hypothesis. Always start with a null hypothesis. It provides a baseline that scientists can test against, helping them determine if their results are significant or if they're due to chance. The null hypothesis, also known as H0, is a hypothesis which the researcher attempts to disprove. Reject or nullify. By attempting to reject this null, researchers can support their experimental hypothesis and draw meaningful conclusions. The hypothesis that there is no difference between the two groups of data and the experimental observations are due to chance. Hypotheses. An example of null hypothesis statement. H0. There will be no difference in plant growth based on the amount of light it is exposed to, or different amounts of light exposure on plants doesn't affect its growth. After the null hypothesis, you want to know the alternative hypothesis, and you will be meant to create one. Start with H1 and then continue. Depending on how many null hypothesis or alternate hypothesis you want to have, you end up adding more. H2, H3, all the way up to as many that you need for the experiment. An example will be more light will allow the plant to have greater growth, or H2, more light will allow the plant to have less growth. So less growth, as you can see there. So we're gonna go ahead and start off with some practice on the hypotheses. So you want to be able to determine a suitable null and alternative hypothesis for the question below. Are teenagers better at geometry than adults? So what would your null hypothesis be? Remember, your null hypothesis is a baseline. It's going to be something you want to try to disprove or reject, so you could draw a meaningful uh, conclusion to your other hypotheses. So for the null hypothesis, you'd might want to write age has no effect on the ability to do geometry. Or you could go ahead and say something like this being a teenager does not affect your skills in geometry rather than being an adult. That would be another null hypothesis because you're just trying to disprove it, and it basically just this variable has no change on this variable. That's what basically you're trying to do. For the hypothesis alternative, you're trying to do if teenagers and adults are given geometry problems to solve, then adults will solve more problems than teenagers because they are older and have more experience doing problems. Or adults may be able to solve geometry problems better than teenagers. You can have an explanation there, but you don't need one. But you want to go ahead and notice, as you can see there, the if right here, and then the then. But for this one right here, you don't always need an if or then, because as you can see, it still works as a hypothesis. It's just a format that you'd be wanting to follow if you didn't know what to do. Some more practice would be a researcher wants to test whether the average weight of apples in a certain region is different from 200 grams. Formulate the null and alternative hypothesis. So the null hypothesis and the alternative hypothesis. If you said that the average weight of apples in the region is 200 grams for your null hypothesis, then you'd be correct. Right here, it's something you're trying to disprove. It's a baseline. You want to be able to have it there just so you can have an experiment that goes against it. So the average weight of apples in the region is 200 grams. That's a null hypothesis. For the alternative hypothesis, you'd want to do the average weight of apples in a region is not 200 grams. As you can see here, there is no if then format. You don't need to follow that format all the time. It's just a baseline for when you're there. For the next one, a pharmaceutical company wants to determine if a new drug lowers blood pressure more effectively than an existing drug. So, what you would do here is it's the new drug. So that's one of the variables and an existing drug. You want to test the existing drug against the new drug. You want to test this drug against this drug. So your null hypothesis, the best one you could go ahead and make would be that the new drug has no effect, excuse me, the new drug has the same effect on blood pressure as the existing drug. And then for the alternative hypothesis, you want to go ahead and support your experiment or refute it. You could put the new drug has a different effect, either more or less, on blood pressure compared to the existing drug. You want to either go ahead and support or refute. For the experimental design, you're going to have groups and variables. For groups, you're going to go into control and experimental. For control, you're going to have a negative and positive group. While in experimental, it's going to be the group you experiment with. And for variables, you're going to have independent, dependent, and constant variables. So let's go into the control and experimental. They're used for comparison. The control, you do nothing to it. It just helps validate, helps give you proof to your experimental groups. It receives the experimental treatment. The IV, which is the independent variable, is being tested to observe the impact on the outcome of the DV. So you want to see what you do to the IV, the independent variable, and how it changes the DV, the dependent variable. You need at least 3 trials needed per group. For the control, there's a negative and positive. Negative is a group not exposed to any treatment or exposed to a treatment known to have no effect. It helps ensure that there is no effect when there should be no effect. And for positive, groups are not exposed to the IV, but is exposed to a treatment known to have effect. Let's say like you had an experimental drug that helps with headaches. That would be your experimental. And then you had a aspirin that also helped with headaches. You know it helps with headaches, and you know the result that it's going to give you, the expected result. And then for the negative, you'd have a placebo pill that doesn't do anything at all. This ensures that experimental setup can produce a known effect, provides a reference point for what the known effect is like. For a negative control, a researcher wants to test the effect of caffeine on heart rate. For your negative control, you're going to go ahead and give it something that has no effect on heart rate. An example would be water. If the water affects the heart rate in the negative control group, then there must be another variable affecting the heart rate or the water is contaminated because the water doesn't affect heart rate. An example of positive control, a researcher wants to test the effect of a new antibiotic on a strain of bacteria. So for the positive control, you'd give it a pill that works on that bacteria. How would the researcher know if the new antibiotic is actually effective? You want to know that. You used an established antibiotic, a known antibiotic that is known to work. That's your positive control group. If the experimental groups fail, but the positive control is successful, it's likely that the tested antibiotics are ineffective. Very likely that they're ineffective because they didn't work the way they were expected to, like the positive control. For the experimental design, we also have variables: independent, dependent, and constant. Independent is the one that is changed between groups. The one factor that is changed between groups, what is being manipulated, graphed, it's graphed as the x-axis. So the independent variable, you apply a sort of change to this to see how that change affects the dependent variable, and it is graphed as the y-axis. And then your constant is the factors that are kept consistent for all the groups to ensure only the independent variable affects the outcome. Creative thinking. Why is it important to only change the independent variable? Think about it. Why is it important to only change the independent variable? Well, it's to ensure that any observed changes in the dependent variable are directly caused by the manipulation of the independent variable. DV stands for, let me write this right here. DV equals dependent, and then IV equals in independent variable. So what's a bias? How can a bias affect an experiment? A bias, as you may know, is a prejudice in favor of or against something. Like, say someone has a bias towards this team, or a lawyer or a judge is biased towards this defendant. Many researchers are trying to prove something by their experiments that in itself is a bias. They have a bias towards something. This can affect an experiment because researchers can interpret or design an experiment around their bias. This is why there are blinds and even double-blind studies to help eliminate biases in an experiment. So, a concept check. Read the problem below and identify the independent and dependent variable. You're washing cars to earn money. For each car you wash, you earn $10. So, what's the independent variable? The amount of cars you wash. What's the dependent variable? You want to see how many cars gives you how much money. For each car, you earn $10. Your independent variable is each car you wash, right here. Your dependent variable is what changes, the amount of money you have. It depends on the amount of cars you wash, which is why it's called the dependent variable. You are interested in how stress affects heart rates in humans. You place humans under different levels of physical stress and measure their heart rate. What's the independent variable and the dependent variable? So you place humans under different levels of stress and measure their heart rate. You want to see how stress affects the heart rate. So, of course, your independent variable is going to be the physical stress exposure you have on that human. The dependent variable is going to be the heart rate, seeing how the heart rate changes based on stress. You want to design an experiment to determine if a new drug has an impact on lowering blood pressure. Test subjects with high blood pressures are given a new medication in pill form. The percentage of patients whose blood pressure decreases is measured. What are the positive and negative controls? So, what is the negative control? A negative control would be, as I said before, a placebo pill, something that has no effect. While a positive control is going to be a drug that is known to reduce blood pressure. It has an expected outcome to compare to your experimental. More practice. You believe that when someone drinks a soda, their heart rate will increase. You set up an experiment using various sodas and various amounts of consumption, and then measure the heart rate on individuals. What are good, positive, and negative controls? So you want to see what's a good negative control for someone who drinks soda and to see how their heart rate increases. So what doesn't do anything? Of course, water. What's a good positive control that's known to increase your heart rate? A lot of you are thinking coffee. Caffeine, technically, coffee, really. But you could also do energy drinks. Coffee works as well. Soda works as well. I know a lot of you are thinking coffee. And that is it for dependent, independent, the experimental design, and hypothesis. We're going to go ahead and go over statistics in biology in a different video as I don't want to turn this into a 40-minute lecture. Thank you for watching and have a great day.